So before we start doing some proofs in this video, I just want to take a minute and practice coming up with conclusions. So let's say we have BD, this line here, this ray, bisecting the angle. And let's go ahead and number these. Now bisecting means it splits it in half. That means those two are congruent. Now if A is the midpoint of QR, what we have to watch out for is we only know A is the midpoint of just this segment. Midpoint is directly in the middle of the 2 points, and it splits the segment into two congruent segments. And the last one, BD bisects AC. You have to be careful. It's bisecting AC. I can only look at this segment here. Now it's bisecting that, which makes it split into two congruent parts. AD congruent to DC. Alright, and let's do some more proofs with triangles. We know that AB is parallel to CD. And we know angle A is congruent to angle C. That's given to us. So, AB parallel to CD. We know angle A is congruent to angle C. Now, because the lines are parallel, angle 2 and angle 1 are alternate interior angles, and because they're parallel, that makes those alternate interior angles congruent. So angle 1 is congruent to angle 2, and that is by, if parallel, then alternate interior are congruent. Oops, spelled that wrong. Okay, so I have two pairs of angles. I need a third piece, and it has to be a side. I can't do angle, angle, angle. That's not going to work for congruency. So I need a side, and conveniently the two triangles are touching, which makes that middle side congruent to itself. DB congruent to DB. And that's because of reflexive property. Now I have an angle, and a side, and the side is on the end, not in between. So it's angle, angle, side. So my triangle ABD, I'm just copying what I see over here. It's congruent to triangle CDB. Make sure you just copy down exactly what you see there. All right. We know angle D is congruent to angle B, and this proof didn't show up quite right. This should be up by the given. This should be the proof statement. We also know that AC is a bisector, and it bisects angle DAB, and that's something to keep in mind, is that it only bisects that one angle. So we have to use it just for that one angle. So angle D is congruent to angle B. AC bisects DAB, which is that top angle. So let's go ahead and number those because I know it's going to split in half. And since it splits in half, angle 1 is congruent to angle 2. And the reason is definition of angle bisector. So now I have two sets of angles congruent. I've got D and B, and then angle 1 and angle 2. Similar to the last example, two triangles are touching. AC is congruent to AC. That's reflexive property. Now I have three pieces of the triangle congruent. Two angles and a side. Angle, angle, side. Now I'm going to copy my proof statement down. ABC is congruent to triangle ADC. Alright, we know, again, this didn't show up quite right. Let's move those around. We know X is the midpoint, and we know that two lines are parallel. So step 1, X is midpoint. And it's important to list which segment it's the midpoint of. It's the midpoint of CD only, and I know that CA is parallel to BD. Oops. All right, so that's my given. Now, step 2, we know that since these are parallel, we know that we have some angles being congruent. So angle 1 and 2, I'm going to call angle 1 and 2 alternate interior angles, so those are going to be congruent if parallel. Alternate interior are congruent. And now for step 3, there's really 2 ways you could do this. So I'm going to do first in red how to prove this. I'm going to say 3 and 4 are congruent. So angle 3 is congruent to angle 4. And that's for the same reason. If parallel, alternate interior are congruent. And then my step 4a is going to be x is the midpoint of CD. So I'm going to use that and say CX is congruent to XD. And that's by definition of midpoint. And I'm actually going to change this just to step 4 because that's going to be the same step 4 for each one. And now step 5 is going to be that the 2 triangles are congruent because I have 2 sets of angles, 3 and 4, 1 and 2, and a side. So triangle AXC is congruent to triangle BXD, and that's because of, in this case, angle, angle, side. So I said I was going to do this a little bit different also. Instead of 3A, we're going to list 3B. I'm going to call this angle here angle 5, and this one angle 6. So in place of 3A, we could do 3B. Let's do that at the bottom. 3B, angle 5 is congruent to angle 6, which makes my reason for 3B all vertical angles are congruent. Now let's take a look at this. Let's see how this changes it. We're going to mark this in purple. I have still angle 1 and angle 2. I still have this side, but now I have the angles here. So my new reason, so reason 5B, would be angle side angle, because the side is now between angles 1 and 5 and 2 and 6. So there are 2 ways to do this, and there are some things to keep in mind there, just as long as you have 3 things and they're in the correct order. Alright, so we have RZ is perpendicular to TS, and angle 1 is congruent to angle 2. So we already know those are congruent. That's given to me. Now, because they're perpendicular, I know angle 3 and 4 are right angles. They're right angles because definition of perpendicular. Now, since they're both right angles, I know they're congruent. Because all right angles are congruent. So I have angle 1 and angle 2 congruent. I have angle 3 congruent to angle 4. What I need to say now is something related to sides, and triangles are touching again. RZ is congruent to itself. That's reflexive property. So I have 1, 2, 3 things in each triangle. That means RZS is congruent to triangle RZT. And my reason, because the side is in between the angles, it's angle side angle. When the side is in between the angles, the S is between the A's.